with RIP we were having some problems, like for an example, this is your R1, this is R2, R3, R4, this is R5, and once again R4. These are serial interfaces, right? And these are Ethernet ports. Let's say this is fast Ethernet 0x0, once again fast Ethernet 0x0, 0x1, this is 0x0, and this is 0x1, and this is once again 0x0, whatever it is. But we are assuming that R1 can reach R4 via R2 as well as via R5. But you know, if you are running RIP over here, then R1 will always prefer this way to reach R4 due to its metric, and its metric is hop count. So it will be considering only and only hop count for its metric calculation. So based on its metric, which is hop count, its best path to reach R4 will always be via R5, right? And that's not good actually, because here we are using serial interfaces, whereas via R2 we are having fast Ethernet links, and fast Ethernet links are having bandwidth of 100 Mbps. 100 Mbps. But here you can see that for RIP, its best path would be via serial interfaces, where bandwidth would be just 1.544 Mbps by default. So that was the main problem with RIP. Like in RIP, its metric was just hop count. It was not considering bandwidth for its metric calculation. And of course, as we saw over there, we came to know actually, like, routing loops can still occur in RIP even after configuring, you know, like even if you are using a split horizon, root poisoning, Poisson reverse, everything, right? But still there were some possibilities of routing loop formation, right? Yes, if you are having small networks. And of course, one another problem with RIP was its convergence. Sometimes it was converged quickly, like if interface was going down, then immediately it was informing to all other routers, right? But in case if it was stopping to receive an update, right, then it was taking so long time to converge. Convergence time was too high in RIP. Right? That was the problem actually. So finally we are going to start now EIGRP, and you know very well that what are the advantages of EIGRP over RIP. However, EIGRP is still distance vector routing protocol. Do you know why do we call it as distance vector routing protocol? Due to hop count, because hop count information will still be there in EIGRP updates. Like if routes are going from one device to another device, then still they will keep hop count information. However, EIGRP is not gonna to use hop count as metric, but still it will keep that hop count information in its updates. Like if you are on R1 and this is R2, this is R3. So if R1 was having a lane network 10.1.1.0/24, then definitely here whenever R3 will receive this prefix, will install in its routing table, it will define it that okay, to reach 10.1.0 it has to across 2 hops. I mean, hop count value will always be there. So that is why we will still call this EIGRP as a distance vector, but actually it is an advanced distance vector routing protocol. You know why? If we call it advanced distance vector routing protocol, because very first reason is that it does not send periodic updates. It sends only triggered updates. which means that whenever there will be any change in topology, then only it will send an update packet. If there is no change in topology, then it will not send any type of update. I mean, there is no concept of periodic update. RIP was sending full updates periodically, right? RIP was sending full updates periodically in every 30 seconds. But here EIGRP is not gonna to send full updates. Even if it is sending triggered update, then also it will not send any, I mean, it will not send full update. Yes, very first time whenever neighborship will come up, then it will be mandatory for EIGRP to send full updates, but then after it will send only and only incremental update. We always says that EIGRP generates triggered, incremental and bounded updates. So what does it mean? Triggered means that whenever there will be any change, then only it will generate an update packet. Second, incremental means that it will send only that information which has been actually changed. It's not gonna to forward full update, right? Third, bounded update, it will forward that information towards those neighbors only who were affected due to change. It's like, for an example, if there is any change in EIGRP, then it will forward that information, that change information towards those neighbors which are which are affected actually due to that change only. If EIGRP thinks that okay, it is not required to forward this information towards this neighbor, then it is not going to forward that information towards that neighbor, right? So we always says that it sends triggered update, second incremental, and third bounded update. So I hope that you have understood the meaning by all these terminologies in EIGRP. Triggered, incremental, bounded. Triggered means whenever there will be any change. Incremental, only that information which has changed actually. Bounded, it will forward this information towards those devices, towards those neighbors only which are having an effect actually, or which are affected due to change. So that's the meaning by triggered, incremental and bounded update. And you must be remember that EIGRP it uses multicast address to send its its messages, right? Like it will be using 224.0.0.10. That is the multicast address used by EIGRP, and it will be using IP protocol number. It's not using either TCP or UDP at transport layer, right? It will directly hand over its payload to the IP itself. So it uses IP protocol number, that is, tell me, 88. Like OSP will be using 89, right? So remember that EIGRP will be using protocol number 88. So point is here, let's say for an example, if there are two routers R1 and R2, and you configured an ACL onto R2 in its inbound direction, and you filtered all that traffic which is containing protocol number 88, right? So you can filter that traffic as well which is coming with protocol number 88. In that case, you will see that they will never form EIGRP neighborship. So to form EIGRP neighborship between two routers, it is mandatory that this protocol number 88 must be allowed. If it is not allowed, then they will never form neighborship. Understood? Fine. In RIP, there was no concept of neighborship. Was there? It never formed neighborship, right? In between two peers, in between two RIP speaking peers. But here in EIGRP, if we are running EIGRP in between two peers, in between two routers, then they will always form neighborship. First of all, they will form neighborship, and then only they will exchange their updates with each other, right? So in between R1 and R2, of course, whenever we will configure EIGRP, they will always form neighborship. So if we are saying that okay, EIGRP will always form neighborship, which means there must be some requirements to form neighborship in EIGRP, right? If those requirements are not fulfilled in EIGRP, then definitely they will never form neighborship. So actually, what are those requirements actually? First, AS number. As you know that in EIGRP we will be using ASs, right? Autonomous system numbers. So I don't think so that it is required for me to explain you that what is the meaning by AS number. You must remember that the range of AS numbers is from 1 to 65535. So you can take any number in EIGRP, and its AS number must match, right? Must match. Second, here in EIGRP we are having some K values. Those K values must match. Third, if you have configured authentication in EIGRP, then also it must match. It is an optional feature of EIGRP, right? If you haven't configured authentication, then it is not necessary to match it, right? Because if it is not configured, then by default it will form neighborship, right? So it's an optional attribute. Fourth, you can, in some cases, you can configure static neighbor, right? So if you are configuring static neighbor, then it is mandatory to configure static neighbor on both sides, right? If you are having like R1 and R2, if you have configured R1 that my neighbor is R2, then it is also mandatory to configure R2 like my neighbor is R1. So if you are configuring static neighbor, then configure it on both sides.
Same as RIP, sir?
In RIP it was not mandatory. In RIP it is not mandatory to configure neighbor command on both peers. It's not mandatory. But in EIGRP that's mandatory. And the reason being is that in RIP there was no concept of neighborship. But here in EIGRP we are having concept of neighborship. Here it will always form neighborship with its peer router, right? So these are the requirements for neighborship in EIGRP. And another beauty is there in EIGRP, like if it is R1 and this is R2, let's say that here its IP address is 12.1.1 and this is /26, and here its IP address is 12.1.2 and its subnet mask is /28, then also it can form neighborship. It is possible to form neighborship with using EIGRP in between these two routers, even if they are having different subnet masks, but make sure that they can ping to each other because you can see that their network IDs are same. The only thing which is required over here is that their network ID must be same. So here you can see that their network IDs are same, and of course, however, it is also not mandatory to match their network IDs as well, but you just need to take care that R1 must be able to communicate with R2, or you can say that neighbor's IP address must belong to our own subnet. So this time you can see 12.1.2 is belonging to this subnet, and 12.1.1 is also belonging to this subnet. So there is not mandatory. I can take another example here. Like I could take here 12.1.60 over here at the end of R1, and then at the end of R2 I could configure 58 on /28 itself. And this time you can see that network IDs are not same, but still they can communicate with each other and still they can form neighborship. But in OSPF it's not possible. In OSPF it is also mandatory to match their subnet mask, right? Hope you have understood this feature of EIGRP. Is there any problem till now? Fine. Now
जो इसके EIGRP में हेलो पैकेट्स जाते हैं उसके अंदर सबनेट मास्क की डिटेल्स होती ही नहीं चेक OSPF में होती है।
OSPF में होती है। Fine. So in EIGRP, you must remember that if you are going to talk about EIGRP, then EIGRP is available into two different flavors now. One is classic mode, that is the older version of EIGRP or older mode of EIGRP, and now they have launched this named mode as well, right? Named mode. So we will be learning this EIGRP into both modes. First of all, I'll cover this classic mode, and then after I'll go for named mode. In named mode, we are having lots of features as compared to classic mode. We do not have those features available in classic mode, but of course we are having those features in named mode, right? So I'll be discussing all those differences in between classic mode and named mode, because there are some, as I said, there are some features which are available in named mode but they are not available in classic mode. So I'll be discussing all those features. So I'll start from classic mode. So let's start it now. So first of all, in EIGRP, we must remember that it sends multicast messages, it sends incremental updates, right? It sends triggered updates, and of course it converges quickly. I'll let you know that why does it converge quickly as compared to our IP. And apart from that, it also conserves network bandwidth. It is helpful to conserve network bandwidth. Are you getting my point with this statement, that it helps to conserve network bandwidth? Conserve means it will save our network bandwidth. You know why? Because RIP was sending periodic update, right? Even without any change. But in EIGRP, because it will send updates in that case only whenever there will be any change in topology. That's why I'm saying that it will help us to conserve network bandwidth. Have you understood it now? So that's the meaning by conserve bandwidth. Of course it converges quickly, and I'll let you know that what are the technical reasons, right, behind this feature of EIGRP that it converges quickly. So this time we are going to start from, first of all, packet types, or you can say message types in EIGRP, right? Message types in EIGRP. So total 5 types of messages are available in EIGRP. First, as you know, hello. Second, update. Third, acknowledgement. Fourth, query. And finally it is reply. So these 5 types of messages are available in EIGRP. Apart from that, we are also having like SIA query, and of course we are having SIA reply. I'll let you know that what are the uses of SIA query and SIA reply, but usually you will be talking about these 5 types of messages only. But if someone asks you that, okay, how many maximum types of messages are available in EIGRP, then total we are having 7 types of messages available in EIGRP. These are the well-known message types, like as we covered them during CCNA and CCNP as well: hello, update, acknowledgement, query, reply. And as you know now, in EIGRP it does not use TCP, right? It does not use TCP at transport layer, and it is not like RIP, because in RIP it was using UDP, that is not reliable protocol, right? RIP does not use TCP, right? It was using UDP, but there was no problem in RIP with using UDP itself. You know why? Because RIP was sending periodic updates. So if any one of the update was getting dropped somewhere in the network, then also it was not a big problem, it was not a big issue, because next time it was delivered onto destination, right? Because it was sending that information periodically towards its neighbors. But here in EIGRP, of course, we can have a lot of problems. Like, if this is router 1, this is router 2, and this is router 3. There was a change onto R1, and because you know EIGRP would send only triggered update and incremental update, and also it is not gonna use TCP. It does not TCP. Even it does not use UDP as well. But I'm saying that it is not using any reliable protocol to transport its messages. So whenever R1 will give this information to R2, let's say that it was delivered onto R2, I mean this update, let's say this interface went down, but let's say due to congestion or due to overhead of CPU utilization, I mean due to heavy CPU utilization of R2, this R2 dropped that EIGRP update, and it didn't send that update towards R3. Of course, towards R3, right? So if let's say that it was dropped by R2 in its input queue itself, or I mean let's say that it was dropped somewhere in the network, right? So now, you know, like if it was dropped somewhere in the network, what can happen? What can happen to your network? Of course, due to some you know, like short of information, there can be a routing loop in your network due to short of information. So routing loops can occur. So, and you know, EIGRP does not send periodic updates. So if it was, let's say that your information that you transmitted towards your neighbor was dropped somewhere in the network, it will never be retransmitted, because it is not sending periodic update. And also it is not using TCP, because if it was using TCP for EIGRP, then definitely it was mandatory for us, I mean for sender, to receive an acknowledgement. And if acknowledgement was not coming onto sender, then sender was, I mean it was mandatory for sender to perform retransmission. But here EIGRP is also not using TCP, and it is sending its updates only once, without any reliable protocol, without any reliability. So of course there are some possibilities of having sort of information, and if there is any sort of information, which means there can be a routing loop. That's the problem. So now to solve this problem, actually it is having external acknowledgement in EIGRP itself, or it will be using a protocol, a special protocol that is known as RTP. That's the part of EIGRP itself. RTP, Reliable Transport Protocol. It's not like TCP, but it will work something like TCP. Because we cannot say that RTP will work same as TCP, because TCP always forms three-way, but RTP is never going to perform three-way handshake. But with the help of RTP, we can have a concept of an acknowledgement. So remember that in EIGRP, all important messages will always get acknowledged. In EIGRP, if you are sending any important message towards your neighbor, then it is mandatory to get acknowledgement, to receive an acknowledgement from receiver. So in EIGRP, as I told you that here we are having some types of messages like hello, update, acknowledgement, query, reply, all these messages are there. So you must remember that hellos are always generated by EIGRP periodically in every 5 seconds. And in some cases it will generate hello messages in every 60 seconds. It depends on medium. Like if you are implementing EIGRP on broadcast multi-access interface or on a point-to-point interface, then by default its hello interval will be 5 seconds. But if you are going to enable this EIGRP onto NBMA, non-broadcast multi-access network, then by default its hello interval will be 60 seconds, right? Like if you enable it onto either frame relay interface or ATM interfaces, then by default its hello interval will be 60 seconds. So you know very well that EIGRP is responsible to generate hello messages periodically in every 5 seconds in most of the cases, right? So usually hellos will be generated by EIGRP in every 5 seconds. So there is no need to have an acknowledgement for hello packets. Of course, there is no requirement, there is no need to receive an acknowledgement from the receiver, from the recipient, right? Because if any one of the hello misses, if any one of the hello gets dropped, right, on somewhere in the network, then another hello, next hello will be delivered onto destination. And if there is an issue onto your link itself, then even TCP is not going to help you out, right? So it is never required, or you can say it is never recommended to use an acknowledgement for hello packets, because these hello packets will be generated by EIGRP periodically. So if any one of the hello packet gets dropped somewhere in the network, then there will not be any problem, right? So that's why we do not use RTP for hello packets, because they are generated by EIGRP periodically. So if any one of the hello gets dropped somewhere in the network, then next hello will be delivered onto recipient, onto destination, or onto neighbor device. The next is update, because you know very well that update packets will be transmitted, will be sent by EIGRP only once, right? It will send update only once. If there is any change, then also it will send its update only once, because update packets will be generated by EIGRP triggered updates, incremental updates, and of course bounded updates, right? So this time it is mandatory for us to receive an acknowledgement, because updates, which means we are talking about routing updates. In update packet, actually it will be having routes information. Your prefixes information will be carried by update packets. So it is mandatory to receive an acknowledgement in response of update packet. So if sender has sent any update packet towards its neighbor, then it is mandatory to receive an acknowledgement from the recipient. If it does not receive an acknowledgement from its neighbor, then definitely it will perform retransmission. It will retransmit its update packet. So remember that RTP will be used by, for update packets by EIGRP, right? Then definitely for query and for reply as well. So remember that if EIGRP speaking router is sending an inquiry packet towards its neighbor, then it is mandatory to receive an acknowledgement from recipient. Even if we are giving a reply, if any router is sending reply message to its neighbor, then also it is mandatory to receive an acknowledgement from recipient, from neighbor. So for these three types of packets, it will be using RTP. I hope that you have understood the uses of RTP, Reliable Transport Protocol. For acknowledgement, of course, we cannot have acknowledgement for acknowledgement. And if you are having an acknowledgement for acknowledgement, then you know very well that acknowledgements will never end up. Never ever. Devices will always keep on to send acknowledgement to each other, right? Once they will receive any single acknowledgement. That is why there is no concept of having an acknowledgement in response of acknowledgement. So remember that acknowledgements for acknowledgement, actually for acknowledgement packet, it will never use RTP. I will also let you know that what are the uses of query and reply as well, but I'll discuss it later on. You know very well that what is the uses of hello packet. If you talk about the hello packet in EIGRP, remember that hello packets are used by EIGRP for neighbor discovery and also to maintain neighborship. If someone asks you that what is the use of hello packet in EIGRP, then you will simply explain that hellos are used to discover a neighbor and also to maintain neighborship. Right? And of course, EIGRP will be using hello packets to exchange that initial information which is required to form neighborship. Because as I said that AS number must match, key values must match, authentication must match, so all this type of information will be contained by hello packet itself. So all these parameters will get exchanged between two EIGRP speaking peers in form of hello packets. So basically with the help of hello packet, it will discover its neighbor, and then once it will discover its neighbor, then after to maintain neighborship, it will also send hello packets. Because you know very well that in EIGRP we are having hold interval, which is by default 15 seconds in case if your hello interval is 5 seconds. Then by default your hold interval will be 15 seconds. Which means that if your neighbor does not, if any EIGRP speaking router does not receive 3 consecutive hello packets from its neighbor, then it will simply break its neighborship. Let's say there are 2 routers R1 and R2. Let's say they have formed the EIGRP neighborship. So if they do not receive hello packet from their neighbor for 15 seconds, or you can say if they do not receive 3 consecutive hellos from their neighbor, then they will break their neighborship, right? And there is a rule in EIGRP that whenever EIGRP will break its neighborship with its neighbor, then it will remove all those prefixes immediately from its routing table which were learned from that specific neighbor, that particular neighbor. It's not like RIP that it will keep all those prefixes for next 3 minutes and something like that, nothing like that, right? So I hope that you have understood uses of hello packet. You have also understood the uses of hold down interval in EIGRP. Update. Update is update packets will be responsible to keep prefixes information. Update packets will always carry forward prefixes information. Prefix and their prefix length. And for update packet, it will always use RTP, right? And as I taught you that if EIGRP speaking router is giving an update packet to its neighbor, if it does not receive an acknowledgement from the recipient, from the neighbor, then it will retransmit update packet. Remember that very first time, like very first update, let's say that there was a neighborship and now R1 wanna send some update packet towards R2, towards its neighbor R2, it will multicast that update packet. First time it will multicast its update packet. Let's say there was no acknowledgement received from the recipient, from the neighbor, then it has to retransmit that update packet.
Yes,
So at the time of retransmission, it will send unicast update packet. It will send unicast update packet. And there is one another rule exists in EIGRP, that if your EIGRP has sent 16 unicast updates without receiving an acknowledgement, it will reset neighborship. It will reset neighborship. If EIGRP has sent 16 unicast updates, and it will send 16 unicast updates towards its neighbor in that condition only, when it is not receiving an acknowledgement. And if there is no acknowledgement received from the neighbor, which means that there is something, something is wrong with your network. So it will reset neighborship. Right? Acknowledgement, you know very well that what is the meaning by acknowledgement. It's just, actually this acknowledgement is kind of hello packet in EIGRP. Inside hello packet they are having this field for acknowledgement. So it is not a separate packet actually. They are using, EIGRP is using this hello packet itself for an acknowledgement. In EIGRP, apart from this, we are also having opcodes. We are also having those. We are also having opcodes. Opcodes are like decimal values of your packet type. Like if it is hello packet, then opcode will be different. For update packet, your opcode will be different. Which means that, just try to understand that if packet is coming to EIGRP, then how is it gonna to be possible for EIGRP to understand that whether this packet is a hello packet, or update packet, or an acknowledgement, or a query, or a reply. So EIGRP will be looking at opcode field, because EIGRP is an application, right? It's a like a kind of protocol. So how will it be possible for that application to understand that okay, this packet is a hello packet, or is an update packet, or is a query, or is a reply? So to understand that, actually it will be using opcodes. So I'll let you know that what are those opcodes. Actually, I'll capture all these packets in Wireshark, and then I'll show you that okay, this is the opcode for hello packet, this is the opcode for update, this is the opcode for acknowledgement, for query, for reply, for all these types of messages. As I told you that EIGRP will use multicast address for sending its messages. That's not true always. Yes, hellos will be multicasted. With using 224.0.0.10. But in some cases, it can also send unicast hellos if you have configured your neighbor statically. So remember that if you have configured your neighbor statically, then it will send unicast hellos. So if someone asks you that the hello packet of EIGRP will be either multicasted or unicasted, so you will simply tell that by default it will be multicasted. But in case if we have configured our neighbor statically, then it will send unicast hellos. Actually, if you have configured your neighbor statically, then all packets, all messages will be unicasted then. If you have configured your neighbor statically. Updates will be multicast, and of course unicast. As I taught you, very first time it will send multicast update, and then after it will send unicast updates. Let's say it has sent multicast update towards its neighbor, but it didn't get any acknowledgement. In that case, it will start to send unicast updates. Acknowledgement will always be unicast. Because if we are receiving any update packet or query or a reply, we will be receiving these packets from a specific neighbor only. So acknowledgement will be given to that specific neighbor only. So remember that acknowledgement will always be unicasted. Query, multicast, always multicast. But in case if you have configured your neighbor statically, then even your query will also be unicasted. But by default, query packets will always be multicasted by default. But if you have configured your neighbor statically, then it will be unicasted. Reply, only and only unicast. Reply will always be unicasted. Let's say R1 has sent one update packet towards R2, but R1 didn't get an acknowledgement back. So it has to retransmit now update, right? So whenever it will perform retransmission, it will always be unicasted. And if you have configured your neighbor statically, then it will always be unicasted. Even very first time also it will send unicast update. Hope you understood all these types of packets. Yes.
तो उस केस में R1 unicast update मेरे पास
Update is different thing. First of all, it has to provide reply and then after it will send an update packet. Update भी unicast होगा, पहले उससे पहले reply आपका unicast होगा.
अगर टोपोलॉजी कन्वर्ट हो रही है तो उस केस में तो मल्टीकास्ट
हाँ, मल्टीकास्ट करता है वेरी फर्स्ट टाइम. Fine. Let's talk about matric calculation. And these rules, whatever I taught you till now, it was applicable for both modes, for classic mode as well as named mode. But now this matric calculation, I'm gonna to teach you this only for classic mode. So if you talk about the matric calculation in EIGRP, in EIGRP, you know very well that we uses like we are not using a specific matrix. Actually we are using composite matrix. EIGRP uses composite matrix. And do you understand the meaning by composite matrix? Group of matrix. Or you can say that it will be using multiple components for matric calculations. Like you know very well that EIGRP considers bandwidth, delay, reliability, and finally I never found this MTU part of EIGRP matric calculation formula. But still it is one of the component of matric calculation in EIGRP, or you can say one of the component of composite matrix in EIGRP. So bandwidth is there, delay is there, load is there, reliability is there, and of course MTU is there. Apart from these components, EIGRP uses some weight values too. You can call them matric weights. Apart from these components, EIGRP will also use metric weights. Do you remember those metric weights? I mean, those metric weight values are known as K values, right? So metric weights. We can also call them K values. So here we are using total 6 K values: K1, K2, K3, K4, K5, and of course K6 is also there. Previously it was reserved. I mean, like, we were not considering this K6, but now in named mode they have started to use this K6. So here, because I'm going to teach you classic mode only, so I'm not going to discuss anything related to K6. So by default your K1 is 1, K2 is equal to 0, K3 is equal to 1, K4 is equal to 0, and K5 is equal to 0. Never think that K1 is equal to bandwidth, K2 is equal to load, K3 is equal to delay, K4 is equal to reliability, and K5 is equal to empty. Never think like that. Usually we think that, okay, K1 is equal to always bandwidth, K2 is equal to always load, K3 is equal to delay, K4 is equal to reliability, and K5 is equal to empty. It is never like that. These are simply weight values. These are simply weight values, nothing else. And these weight values are used in EIGRP just for metric manipulation. To manipulate your metric, we can modify these K values. You know, like if you configure K1, its range is always 1, 2, 2, 4, 5. If K1 is equal to bandwidth, then its range should have been like 1 to 1000 kilobits or megabits or something like that. So never think that K1 is equal to bandwidth, because by default we are having K1 is equal to 1, which means bandwidth is by default 1 kbps or 1 mbps or 1 gbps. What is that? K1 is equal to 1. Yes, in other words, we can say that with using these weight values, we can modify our formula so that we can define that whether we will consider bandwidth for metric calculation or not, whether we will consider delay, load, or reliability for metric calculation or not. So these things can be defined by modifying K values. It does not mean that K1 is equal to bandwidth. Yes, by modifying K values, we can modify consideration of composite metric or these components like bandwidth, delay, load, and reliability. You know, if K2 is equal to 0, and in that case it does not consider load. You know why? Because if K2 is equal to 0, then in formula it will make this it will make this load value as 0 as well. Because if you multiply by 0 to anything, to any number, it will make it 0. So that is why it will not consider this load for metric calculation. Right? I'll show you that what is that formula actually, in which we will be having all these components except MTU like bandwidth, delay, load, reliability, and of course these all K values. Right? And because this, you know, if you talk about the entire formula for metric calculation in EIGRP, and you know what I mean, what's the meaning by bandwidth, delay, and load reliability over here? See, these two metrics are known as fixed metric in EIGRP, or you can say yes, it will be fixed metric. And load and reliability, these are considered as a variable metric. And because load and reliability are variable, I mean these two values are always variable, that is why by default it is never recommended to use load and reliability for metric calculation due to variable values only, because load can get changed anytime, reliability can get changed anytime. I mean reliability value, by default reliability is higher 255 on to all interfaces, but it can get changed anytime. Similarly, load can also get changed anytime. That is why it is not recommended to consider load and reliability for its metric calculation. Because if you are considering load and reliability for metric calculation in EIGRP, so whenever there will be any change in load, in either load or reliability, then metric calculation formula will get changed. And if metric calculation formula will get changed, then definitely your metric will get changed. And if metric is getting changed periodically, then your routing table will not be consistent. And we always try to have a consistent routing table in production environment. Because if routing table is not consistent, then your path followed by your data will not be consistent. And we always want consistency in our network. So that is why by default Cisco does not consider load and reliability for its metric calculation. But remember, we can modify our formula so that it will start considering load and reliability for its metric calculation. So have you understood it, that why Cisco does not recommend to use load and reliability for its metric calculation? Due to variable values. Load can get changed whenever you will increase a load onto your interface. Let's say you are having an interface of 100 Mbps bandwidth. Previously you were transmitting data at rate of 10 Mbps, then you started to transmit your data at rate of 20 Mbps, then 30, 40, 50, 60, so load will keep on to increase. So if load increases, then definitely your metric formula, your metric will get changed. If reliability value gets changed, then also your metric value will get changed. And you must remember that lower metric is always preferred in EIGRP, right? Lower metric is always preferred in EIGRP. And always, you must always remember that if bandwidth is higher, metric will be lower. If bandwidth is lower, metric will always be higher. Means bandwidth and metric are always inversely proportional to each other. Bandwidth is higher, metric will be lower. Bandwidth is lower, metric will be higher. In case of delay as well, if delay is higher, if delay is higher, then it will be metric will also be higher.
It is directly proportional.
Exactly.
Delay is proportional.
Right? So if delay is higher, then metric will be higher. If delay is lower, then metric will also be
Again opposite.
of course. It is same as bandwidth actually. If delay is higher,
Matric is lower.
now it is also, my last statement was correct actually. You are making me confused now. If delay is higher, metric will always be higher. If delay is lower, then metric will be lower. So lower delay will always be preferred, whereas higher bandwidth will always be preferred, right? In case of load, lower load will be preferred, will be good. Higher load, if load is higher, then metric will be higher. If load is lower, then metric will also be lower, if we are considering load for metric calculation. But in case of reliability, again it will be same as bandwidth. Higher reliability, low metric. Low reliability, higher metric. It is same as bandwidth. Right? And by default K1 is equal to 1, K2 is equal to 0, K3 is equal to 1, K4 is equal to 0, K5 is also equal to 0. These are the default K values, these are the default metric weight values. And the actual formula for metric calculation in EIGRP is Yes, this is the formula for matric calculation, and this is the older formula actually. I mean, I'm talking about classic matrix. This is the actual formula, and here you can see 256 multiplied by K1 and again multiplied by scaled bandwidth. And now you must be having an information that how to calculate scaled bandwidth and scaled delay, because in this formula in some on some places you will find scaled bandwidth and scaled delay. So in this formula you can see K1 multiplied by scaled bandwidth plus K2 multiplied by scaled bandwidth and divided by 256 minus load plus K3 multiplied by scaled delay and again multiplied by K5 divided by reliability plus K4. Now in this formula, if you put K1 is equal to 1, K2 is equal to 0, K3 is equal to 1, K4 is equal to 1, K5 is also equal to 1. So finally your formula will be something like this. It will be your formula. I mean, this is, if K1 is equal to 1, K2 is equal to 0, K3 is equal to 1. I mean, if you are using default K values, then it will be your formula, because if you put those values over here in this formula, then finally your formula will become something like this. That is why we always uses this formula, this one. Like if you remember from CCNP, you learnt about EIGRP Matric Calculation formula in this way, like it was 10 raised to the power 7 divided by bandwidth. Do you remember that?
Yes.
Bandwidth plus total delay divided by 10 and multiplied by 256. In other words, this field 10 raised to the power 7 divided by bandwidth is known as scaled bandwidth. This is known as scaled bandwidth. Actually, this is the formula to calculate your scaled bandwidth, and this is the formula total delay divided by 10. This is the formula to calculate scaled delay. This is the formula to calculate your scaled delay. Total delay divided by 10. This is the formula to calculate your scaled delay, and 10 raised to the power 7 divided by bandwidth in kbps. You must remember that while you are calculating your scaled bandwidth, make sure that in formula you are putting your bandwidth in form of kbps, and you will always consider the lowest bandwidth, right? Lowest bandwidth from source to destination. So finally this is your formula to calculate your matrix in EIGRP, just because of we are having K2 is equal to 0, K4 is equal to 0 and K5 is equal to 0, right? If we start to consider to use K2, K4 and K5, you will see that now it will start considering reliability and of course load. Because if K2 is 0, then you can see in this field, if K2 is 0, then load will also not be considered. You can see, you can look at this. Because if K2 is equal to 0, then it will make scaled bandwidth as 0 itself. Like 0 multiplied by any value, it will make it 0. And if you are dividing to your 0 by any number, then again it will be
0.
Understood? That is why previously, I mean, in actual formula, I mean, when you are having your K2, K4 and K5 is equal to 0, then you are not gonna to consider your load and finally this reliability. Fine. So finally your formula is this one, 256 multiplied by scaled bandwidth plus scaled delay. That's the original formula That's the default formula of EIGRP actually. So now it's really simple to calculate matric. Let's say there is an interface of 100 Mbps and its delay is, let's say, 100 microseconds, right? So formula will be now 10 raised to the power 7, which means 7 zeros divided by 100 Mbps, which means 100, 1000, and once again 1000. 100,000, 1000. That will be I have converted it into kbps now, or oh my god, 100,000 only. 100,000 kbps will be 100 mbps.
1 Mbps.
1 mbps is 1000 kbps. 100 mbps means 100,000 kbps, right? So plus total delay, which is 100 microseconds, divided by 10 and multiplied by 256. So this time you can see 5 zeros will be dismissed, and here it will become 10, and now it will become 110, right? Multiplied by 256, so it will become now 0, 6 and 1, 6, 2, 8, 1, 6, 0, right? So it will be your output. So if you are having any interface of bandwidth 100 Mbps with 100 microsecond delay, then it will be matric for that interface actually of EIGRP, or EIGRP will be calculating your matric in this manner. Understood?
Get the power priority and
Just for the manipulation of EIGRP metric calculation. Like you can look at the formula if you wanna include like now reliability, then use K5. Do not use it as 0. It does not mean that K5 is equal to reliability. No, it's not like that.
K5 is for MTU.
I never said like that.
It's corresponding to.
No, never. You see, in this formula there is nothing like MTU.
No, there is not. Then if we count K1 to K5, then can we correspond to them or no? Or they are independent?
They are independent. If K5 is equal to MTU, then K5 must have been
Not equal to,
configured.
corresponds to.
I don't think
I didn't
so.
say equal to. No.
I will not say. I will never say that
So we
K5 is
can't
equal to
relate.
MTU. You can't relate it with MTU. You can say that if we are considering K2 and K4.
I was just trying to follow the analogy. If we change K1, then bandwidth changes according to that, in that proportion. So I was assigning that corresponding.
No. If K1 is how?
Means bandwidth is affected. If we make K1 0, bandwidth is 0.
These are the bits value.
अगर जब हम
So in that way I was just making that analogy.
देखो, अब इस पे बहस करने का कोई फायदा नहीं है. मुझे पता है तुम ऐसे ही करोगे. ये मेरे को पहले से पता था. मैं फिर से रिपीट कर रहा हूँ, ये सिर्फ वेट वैल्यूज होती हैं और वेट का मीनिंग वेट ही होता है. अब मैं से ज़्यादा कुछ नहीं बता सकता इसमें. उन्होंने फॉर्मूला बनाया, ये उन्होंने बाय डिफॉल्ट इनकी वैल्यूज रखी, बट कभी भी ऐसा मत समझना कि K1 इज इक्वल टू बैंडविड्थ.
No, not equal to.
मैं फिर भी आप कोरस्पोंडिंग कैसे कह सकते हो जब फॉर्मूला में K5 है बट देयर इज नो MTU, राइट? तो आप कैसे कह सकते हो कि K5 इज कोरस्पोंड टू MTU? आप देखो ना फॉर्मूला में, इफ K5 इज देयर बट MTU इज नॉट देयर, तो हाउ कैन वी से दैट K5 correspond to MTU? Even if you look at this formula, K1 is there, K2 is there along with scaled bandwidth. You can look at the formula. अगर K1 बैंडविड्थ को ही कंसीडर कर रहा होता है यहाँ पे, तो K1 के साथ ही बैंडविड्थ आना चाहिए था, यहाँ पे K2 के साथ क्यों दिया हुआ है? आप देखो फॉर्मूला में, K2 इज ऑल्सो मल्टीप्लाइड बाय स्केल्ड बैंडविड्थ अलोंग विथ K1. तो मैं सिर्फ ये कह रहा हूं कि दीज आर दी वेट वैल्यूज एंड आर जस्ट यूज टू मैनिपुलेट योर मैट्रिक कैलकुलेशन.
Basically, we have to go with this formula.
हाँ, of course you have to go through this formula. हाँ.
Like if I say I'm having K1 value of 1,
Mm-hmm.
so I calculate like K1 in case of K1 I expect 1 and then after that I'll calculate whole scale bandwidth or something.
मैं फिर से वही बात बोलूंगा. These are the K values, these are simple weight values, are just used along with these components which are used by EIGRP for its metric calculation. And these K values will be just used to manipulate your metric calculation. बस इससे ज़्यादा कुछ नहीं है. आप कोरिलेट मत करो K values को बाकी components के साथ में. आप कोरिलेट करोगे, कंफ्यूज हो जाओगे. मुझे पता था ये पूछोगे तुम लोग. आप फॉर्मूला की तरफ थोड़ा सा ध्यान दोगे तो सारी चीजें क्लियर हो जाएंगी इसमें. अगर कुछ ऐसा होता कि K1 बैंडविड्थ को रिलेट कर रहे हैं यहाँ पे, तो ऑब्वियसली बैंडविड्थ शुड हैव बीन यूज्ड विद K1 ओनली. बट इन फॉर्मूला वी कैन सी दैट K2 इज ऑल्सो यूज्ड देयर अलोंग विद स्केल्ड बैंडविड्थ. तो K2 को तो फिर लोड के साथ ही यूज होना चाहिए था ना, जैसा हम CCN में पढ़ते थे कि K1 इज इक्वल टू बैंडविड्थ, K2 इज इक्वल टू लोड, K3 इज इक्वल टू डिले. देखो वहां पे ऐसा बताना जरूरी है. मैं भी अगर CCNA कराऊंगा तो मैं फर्स्ट लाइन में यही बोलूंगा K1 इज इक्वल टू बैंडविड्थ, K2 इज इक्वल टू लोड, K3 इज इक्वल टू डिले, बिकॉज वहां पे आपको ये सब चीजें समझ में नहीं आने वाली है. अब थोड़ा सा समझने की कोशिश करो कि these are, I mean these K values are not equal to, you know, like these components which are used by EIGRP for its metric calculation. These are separate values actually, and we call them as weight values, nothing else. Weight आएगा आगे क्वालिटी ऑफ सर्विस में भी, वहाँ पे भी बताऊंगा कि वेट क्या होता है. वहाँ पे भी एक टर्मिनोलॉजी आती है वेट, तो थोड़ा तब जाकर के क्लियर होगा. फिलहाल अभी कोरिलेट नहीं करना है इसको किसी के साथ भी. बस ये समझना है कि these are the default K values. If you modify K values, then definitely EIGRP metric calculation formula will get modified. You see, uses bandwidth, delay, reliability, load and अगर K वैल्यूज उन्हीं को रिलेट कर रहा होता है यहाँ पे, तो ये एंड में नहीं लिखेगा फिर K वैल्यूज को. फिर ये सिंपली बस यही लिख रहा होता है कि इट विल यूज K वैल्यूज या फिर इट विल यूज दिस कंपोनेंट. इसने कहा है EIGRP uses bandwidth, delay, reliability, load and K values, not MTU. Various constants that can be, K values का मीनिंग है ये ब्रैकेट्स में, various constants that can be configured by a user to produce varying routing behaviors. आ गए आप समझ में? अब तो नहीं करोगे ना इसको कंपेयर की K वैल्यूज को बैंडविड्थ, लोड, रिलायबिलिटी. ठीक है, चलें आगे अब. फाइन. हाँ सर,
कंफ्यूज करने वाला है
नहीं, कंफ्यूज करने वाला नहीं है, वेरी सिंपल है. वेट वैल्यूज है, कुछ नहीं है अलग से. बस वी यूजेस दैम इनटू EIGRP मैट्रिक कैलकुलेशन फॉर्मूला, और इसको मॉडिफाई करके हम फॉर्मूला को मॉडिफाई कर सकते हैं एज पर आवर रिक्वायरमेंट. वेरी सिंपल. Now if you look at the formula, if I use only K1 is equal to 1, which means that we will be considering only and only bandwidth. if you put k1 is equal to 1 and all other k values are 0, you put all those values in this formula and then you will come to know that now you will be considering only and only bandwidth for its metric calculation. हाँ जी, हाँ जी बिल्कुल 0 to 255 के बीच में कोई भी आप वैल्यू सेट कर सकते हो फॉर एनी के वैल्यू. Apart from that, if you put k3 is equal to 1 and all other k values are zeros, then you can look at formula that you will be considering only and only delay.
तो K5 को 1 कर देते हैं
तो अब निकाल लो फिर फॉर्मूला में रख के जो भी निकल के आएगा. K5 को 1 कर दोगे, K4 क्या है 0, तो फिर ये कंसीडर होगा और K3 भी कंसीडर करना पड़ेगा बिकॉज अगर K3 ही 0 है ऊपर तो 0 को जब आप किसी से मल्टीप्लाई करोगे तो वो ऑटोमेटिकली 0 हो जाना है.
आगे चलते हैं.
Fine. So these are the default k values and finally this is your formula as I told you 10 raised to the power 7 divided by bandwidth in kbps plus total delay divided by 10 and multiplied by 256, or in short we can say scaled bandwidth plus scaled delay multiplied by 256 if you are using default k values. Done. So this is the formula for metric calculation. Fine. If we are using this formula, it was good. I mean this formula was good till we were having bandwidth up to 10 gig. But nowadays you can see that we are having bandwidth like 20 gig, 40 gig, even 100 gig. Or more than 100 gig as well. We can we can bundle multiple links of 40 gig between switches, so we can have bandwidth more than 100 gig as well. So if you are having that much bandwidth, and one more thing that I would like to tell you, that it does not matter that what is your bandwidth, but delay cannot be configured less than 10 microseconds on any interface. This is the lowest delay. Delay cannot be configured lower than 10 microseconds. So like if you are having an interface of 100 Mbps, then by default its delay is 100 microseconds, but if you are having interface of 1 gig, then it is 10 microseconds. And now if you are having interface of 10 gig, then also its delay will be 10 microseconds. Of 100 gig also its delay will be so remember that delay cannot be configured lower than 10 microseconds. Now this EIGRP metric calculation formula got failed. And one more thing, that in classic mode your metric value can be maximum 32 bits long value. Which means like it is something like 4.2 billions. Maximum metric can be 32 bits long metric with using this older formula or in classic mode, right? So now problem came into the network when we are having bandwidth higher than 10 gig. And let me tell you, let's say for an example, if you are having this R1 and this is R2, this is R3, and R2 and R2 is receiving same prefix from both neighbors. Here its bandwidth is 20 gig and here it is 40 gig. Let's calculate their metric now. for both interfaces with using this older formula. So if we are using older formula to calculate its matrix, then for 20 gig it will be something like this. See, 10 raised to the power 7, which means 1 0 0 0. Okay, so this is 10 raised to the power 7. 7 zeros are there. 20 gig, convert it into kbps now. So which means it is going to be 20,000. One more 1,000, right? So 20,000, and now plus total delay divided by 10. So 10 divided by 10 multiplied by 256. So here, because scaled bandwidth cannot be, okay, it will become now, you will consider it as 0. You will not consider it like 0.5. You will never make it 0.5. Scaled bandwidth cannot be in points, in decimals, right? It will be like either 0, 1, 2, something like that, right? So 0 plus 1 into 256. So overall it will become 256. Now if you are having bandwidth of 40 gig, it will also 256. Even if you are having bandwidth of 100 gig, then also its matrix will remain as 256. So there will not be any difference in its matrix calculation if it is having its diagram in that manner as I defined you, right? So this formula got failed in such scenarios, and that is why finally Cisco decided to launch wide matrix. Fine, I'll be discussing. Have you understood this problem with older formula, that with the different bandwidth? समझ में आ गया आप लोगों को कि this formula got failed if we are having interfaces with these bandwidths like 20 gig, 40 gig, 30 gig. I mean, if you are having bandwidth higher than 10 gig, then all those interfaces which are having bandwidth higher than 11 gig bandwidth, then all of them are having same matrix. There is no difference in their matrix. So finally they launched wide matrix now, and in wide matrix, first thing that you have to understand that now your matrix can be represented in 64 bits long value. Your matrix can be represented in 64 bits long values. Second, they have also modified formula. They have also added some new components in its matrix calculation. Apart from those, like now in wide matrix, they are calling this bandwidth as throughput. They are calling this delay as latency. Load is load, reliability is reliability, MTU is MTU. They have renamed bandwidth and delay. Do you understand the meaning by that? The matrix will be represented in 64 bits long value. I mean, matrix can be up to 64 bits long value. Like 32 bits, 2 raised to the power 32. 64 means 2 exponent 64. Understood? Apart from load and reliability and MTU, here they announced 2 new components as well. One is jitter and another one is energy. These 2 new components are added in wide matrix. jitter and energy. But still by default it will be using bandwidth and delay for its metric calculation. Here in wide matrix we are having K1, K2, K3, K4, K5 and K6. K1 is equal to 1, K2 is equal to 0, K3 is equal to 1, K4 is equal to 0, K5 0, K6 is also 0. So here we are using 6 K values, and the formula to calculate your metric, here actually in wide matrix they are having formulas according to bandwidth. As per bandwidth, formula will get changed automatically. If bandwidth is higher, I don't remember exactly that value, but in that case it will get changed automatically. You see, this is the formula actually, the actual formula. You see, 64-bit metric calculation work only in EIGRP named mode configuration, right? So now in named mode your metric can be up to 64 bits long. Second, this is formula. In this formula you can see that they are having minimum throughput, they are having load, they are having total latency. You know, minimum throughput means like kind of minimum bandwidth. Previously we were considering minimum bandwidth, right? But this time they are considering minimum throughput. Then they are also having extended attributes. Do you understand the meaning by extended attributes? Meaning by extended attributes is jitter and energy, and K5, K4 and once again reliability. So this is new formula to calculate your metric in named mode.
थ्रूपुट और बैंडविड्थ में कुछ डिफरेंस होता है?
वो फॉर्मूला है यहाँ पे to calculate your throughput. See, this is the formula. Minimum the formula to calculate minimum throughput is 10 raised to the power 7 multiplied by 65536 and divided by bandwidth in kbps, where they are taking this 65536 as a wide scale constant. So this is the formula to calculate your minimum throughput. That's the difference in between throughput and bandwidth. Actually not throughput and bandwidth. This is the difference in between minimum throughput and the bandwidth.
In general कोई पूछे कि bandwidth और throughput में
होता है एक छोटा सा डिफरेंस. अगर जनरल बात करें तो वो अलग है. यहाँ फॉर्मूला में मीनिंग बाय थ्रूपुट एंड बैंडविड्थ इज क्वाइट सेम, राइट? But generally meaning by throughput and bandwidth is different. Like if someone is saying bandwidth is 100 Mbps and if it is working if that interface is working in full duplex mode, then definitely its throughput will be 200 Mbps. That's the difference in between bandwidth and throughput. So now you can see to calculate to calculate latency. Formula is different when it is calculating delay for those interfaces which are having bandwidth below than 1 gig. In that case it will be your formula to calculate your latency. If your interface's bandwidth is higher than 1 gig, then the formula to calculate your latency will be this. So that's why I said that as per the bandwidth of interface, named mode will change its metric calculation formula, and it will be done by EIGRP automatically. You will never is required to specify that okay, we are having bandwidth higher than 1 gig, so use this formula or use this formula. We will never require doing that. So we will simply configure EIGRP named mode and all these things will take place automatically. One more thing that you must remember now, that with using this formula, now it can accommodate interfaces with bandwidth up to Till that EIGRP formula is not gonna to fail this time.
What should work for 1 gigabit bandwidth exactly? And it is written below 1
I don't
gigabit
know.
or-
Even I also don't know. It only this answer I can get from Cisco only. I have also read this document only for white matrix. I don't have anything else to read about this from anywhere. But what I think that till 1 gig, it will be using this formula. This one only, and then higher than 1 gig, this one. And if bandwidth is higher than 1 gig, then it will be using this formula. And for testing, I do not have any equipment over here because we are not having devices who are having interface bandwidth higher than 1 gig. Even sometimes on most of the devices we are having bandwidth of 100 Mbps only. But yes, I can connect switches with using fiber optics, so I can get bandwidth up to 1 gig, but not more than 1 gig. So that's not possible for me. So hope you have understood it. And one more thing that I would like to show you, adjusting EIGRP metric weights can dramatically affect network performance. Because of the complexity of this task, we recommend that you do not change the default K values without guidance from an experienced network designer. तो ये डिजाइनर का काम होगा, इतना ज़्यादा डेप्थ में जाना हमारा काम नहीं है. हमारा जितना था, we have learned that, right? So hope you have understood the differences, main difference in between classic mode and named mode, especially in their matric calculation. Some other differences are too, but I'll be discussing all those differences during configuration only. Like there are some features in named mode EIGRP, right? So we will be doing that configuration in named mode EIGRP, but this was the difference in their matric calculation. That's fine. That's the only thing. That's all about actually your white matrix. If you want to ask anything else related to white matrix or classic matrix, please let me know. I taught you matric calculation formula for classic mode as well as for white matrix for named mode. And remember, these white matrix will be supported in named mode only, not in classic mode.
अभी आपने कहा सर कि बैंडविड्थ को इंक्रीज फाइबर ऑप्टिक्स लगा के 1 गीग कर लेंगे, वो कैसे?
नहीं, वो है ना हमारे यहाँ पे अपलिंक पोर्ट स्विचेस पे 3750.
अच्छा, अपलिंक पोर्ट वो 1 गीग को सपोर्ट करते हैं.
Fine. So that's all about matric calculation in EIGRP. Let's talk about types of tables available in EIGRP. First, neighbor table, routing table, and topology table. These three tables will be there in EIGRP. Now you know very well in neighbor table it will have an information about its neighbors. So if it is having 2 neighbors, 3 neighbors, then it will keep that information in its neighbor table only. Routing table routes only. Topology table I will be having some information in it, and right now I'm not going to explain the components of topology table, because before going to explain the components of topology table, like here we are having some terminology: successor, feasible successor, feasible distance, reported distance, you understand? So we have to discuss all those terminologies first before going to discuss this topology table. But you must remember that in neighbor table it will be having neighbors information, right? Some components are there about neighbors, like neighbors IP address, exit interface, the hold down timer, uptime, right, and SRTT, smooth round trip time, and RTO, retransmission timeout, right, and of course sequence number of last received update packet. So these components are present in neighbor table, or you will find these components within the neighbor table. Routing table will be responsible to keep only best routes in it. So in routing table you will always find best routes available, and in routing table you can have three types of routes in EIGRP. First, internal route. Second, external route, means redistributed routes. And third, summary routes, because you can also configure summarization in EIGRP. And for internal route, by default its AD value is 90. For external it is 170. For summary it is 5. Terminologies. In EIGRP, like you are having successor, feasible successor, feasible distance, advertised distance, or we can call it reported distance. Successor is like best path. In EIGRP, best path will be known as successor, or we will call that path as a successor. So a best path will always be known as successor. Feasible successor, kind of backup path. So EIGRP is one of the protocol, or you can say it's the only protocol which can provide backup path, because of dual diffusing update algorithm. This is the algorithm actually used by EIGRP for everything. This algorithm is responsible for doing everything in EIGRP, like to generate hellos, to send updates, to generate query messages, to perform retransmission, to define best path, to define backup path, for everything, to prevent network from routing loops. For everything this algorithm is responsible. Dual diffusing update algorithm. So this feasible successor is kind of backup path, and you know very well, to become feasible successor there is a condition of feasibility. There is a condition actually to become backup path. If that condition is not fulfilled by backup path, I mean by alternate path, then it will never become feasible successor. So to become feasible successor there is a condition, and that is known as condition of feasibility. And I'll let you know that what is that condition of feasibility. Any problem? So then feasible distance is there, total metric, right, of successor. Metric of successor, right, is called feasible distance. Advertised distance, reported distance given by neighbor. Metric to reach destination prefix given by neighbor, right? A metric given by neighbor to reach destination prefix is known as advertised distance, or you can say reported distance. We do not have enough time to to demonstrate, because I have to demonstrate it once again with using a diagram. So with using diagram you will come to know that okay, this is successor, this is feasible successor, this is the condition of feasibility, this is feasible distance, this is reported distance. So I'll be discussing it, but it will not get completed within 5 minutes, so it will take more than 5 minutes, so I'm gonna to save it now.